Hi there, welcome to the breadboard. This is part of the TEVO Black Widow assembly. In this video we're going to finish off installing the drag chains, connecting all the wires up, and assembling the power control box and doing our first test print. So to get started, the first thing we're going to be doing is installing the drag chain. So we have a mount up here for one, and there's going to be one somewhere to go vertical as well to get out to the control box. The page, if you're following along in the manual, is page 36 and 37. That's where we're at right now. I'll go grab the parts and start getting them mounted. So as you can see here with this cable chain, it's actually both the X and the Y cable chain in one. They've just ran the wires all the way through right down to here, which is going to be going into the controller, I'd imagine. And so we're starting with this end that needs to come up here. We have the connections for the extruder, the thermistor, the heater, and the fan. And when you've built a few 3D printers, you get to know what each of those wires look like when you're assembling them. Now, this is not very clear, and I'm doing this backwards, how these mount, but I'm pretty sure that this one is going to be running along back here. So there's one rather large screw hole there for mounting. It's almost like it's given up giving you the details here. So what we need is a screw. Yeah, got to find the right screws because they've kind of given up telling us anything. Just pictures now. Okay, so B23 appears to be the drag chain bag, though I don't see any small screws for mounting the drag chain. So it'll be interesting to see how that's supposed to work. Anyway, I will start doing that and see what I can find. Okay, so that's the cable chains on. One mounting point right here. One mounting point here, but you got to put a bracket on, which is not talked about in the instructions. I'll take some close-up pictures anyway. So you've got 1, 2, 3 T-slot nuts going in here. 2 of them are on this bracket. One of them is on the end of the cable chain. There is one of the T-slot nuts going in here to mount onto the head plate, mounting plate. You just ignore the T-slot nut and just go with the screw, because you have to kind of force it through the plastic a little bit, but then it will thread right into the mount, no problems at all. It doesn't take a lot of effort. Same for this end. You force it through the plastic and then put a T-slot nut on the back of it. On the other end of this little bracket that curls around here, as I said, I'll take some close-up pictures. There is another screw threaded hole on the bracket to take the top of the cable tray, and then it feeds to the bottom, and then you jam a screw through the cable chain again and put a T-slot nut on and fasten it to the bottom of the rear of the frame, and then you just have the cables laying around waiting to be connected to motors and limit switches. And I did notice, looking at this, the limit switches that are on this TEVO Black Widow are actually Hall effect sensors. Really, really tiny little numbers that just, they're not micro switches. That's the point. So they're going to be a little more immune to noise and dust and stuff like that. And they look very nice. So we'll see how well they perform. And pictures for each of these. So we've got the one for the head. We've got the one for the Z-axis mounting plate. And then we have the one at the bottom of the Z-axis. Next is to install the limit switches. I'll just install them. The instructions are very clear about where they go. I'll install them, take some pictures, and show you. The limit switches, by the way, are already cabled into the cable chain, so there should be no ambiguity as to which ones are for what. Okay, so that is the limit switches installed and the extruder controls all plugged in. The next thing to do is to construct the controller. So that's what we'll do now. Okay, now we have the control box to build. So the parts we have here are the 24 volt power supply, a 24 volt fan, the on-off switch and mains input connector, a MOSFET for driving the heat bed, bunch of screws and standoffs, LCD display for the controller, and the controller itself with a whole boatload of wiring pre-plugged in. And the stepper drivers are all plugged in with one extra. And we also have a pile of flat pack laser cut acrylic sheets that will be assembled into the box. So first things first is it wants us on page 40 to assemble the main part of the case using the acrylic, and then putting the outer parts, which are the logoed with TEVO, onto that. So it says assemble the control box as shown in the following pictures using M4 by 12 bolts and M4 nuts. Install the power supply, LCD main board and fan in the box using spaces provided with the kit. Use M4 12 bolts and M4 nuts to assemble the casing. It's telling us that twice. So it shows pictures of the general layout. It does not show us anything closer than that. So for this thing, which has mains in it, there is no word about connecting up mains properly. There is no word about cable management or anything like that. And there's nothing that I don't think shows us even how to, no, it goes on to the software there. So there's nothing that shows us anything about wiring the inside of this case. So I got to make it up as I go. I'm pretty sure it's going to be fairly intuitive, but we'll see. We'll start with the acrylic. Here's all the acrylic we need. So let's lay this out. This is going to be for the back because it's where the fan goes. We've got the IEC connector and a great big gaping hole. Probably front. That looks like it's for the LCD display. That's one of the TEVO logo pages, sides. So I'll move that aside. That is an actual side. That's another TEVO side. That's the other side. They look like they are not identical. So I guess one is for having the SD card plug in and out when the display is near the front. So we know where that's going to end up with. This would be a bottom power supply mounting holes. And that one has absolutely no screw mounts or anything. It's probably going to be the top. And that will be on the front at the bottom, guessing. So first things first, I guess, is to remove some of this plastic and bolt these initial parts together. So this is the case. Yeah, I haven't put the screws or the nuts in yet, so it's just sitting here by gravity and staying together. Looks actually quite nice. Plenty of holes for ventilation. Hopefully no holes to get your fingers in for mains. So let's get all the screws in and then we'll start assembling the components. So when assembling the controller, one of the things you have to be aware of is it's first of all easier if you keep one side off, just so that you can do the panel bolting it down, the power MOSFET to bolt it down, etc. All of the cables are just going to run out of this hole at the end of the case. Not really ideal, it's just a great big hole. There's no clamping down or anything like that, but that's the way it is. The power supply tucks hard against the edge and the mains end is at this end. So you want to try and route your mains cables as far away from all your other cables as you can, which is perfectly doable. Just tuck them off the side. Some of these are long, you can shorten them quite considerably, like the ground wire and the neutral. That's the 12 volt fan for the case, sorry, 24 volt fan. That's going to connect directly to one of these connectors on the back here. So you have to plan the wiring carefully. Now I think from what I'm seeing, it is going to be easier if I have the FET drivers on the controller at the bottom of the board, because if I want to add some extra things later, then I can get to them easily without taking everything apart, because all of the additional controls and things are at the top. The sensors, only the stepper drivers connections are at the bottom. It does mean that the power connectors are at the front here though, But if I look in the book, that is basically how they have it there as well anyway. At least this, from the few diagrams that I can see, that's the way they have it. They really don't show the MOSFET board in here, so you got to figure out that for yourself, although there is a separate supplement sheet that will show you that. What I'm going to do though is I've got a bunch of additional cable ties. I'm going to neatly wrap up some of these cables into little bundles for routing to keep it cleaner. I don't like blocking fans with a whole bunch of cables and everything else. The LCDs at the front and the cables for it are way at the back, but there's plenty of length to reach once this is assembled, and it shouldn't block too much of the heat. So that I think is okay. I'm just going to see what extra pieces of wire came with this, because there were some loose pieces of wire for wiring up the higher powered stuff. There was a bag that came with the kit that was labeled gift. What was in here was an 8 gig SD memory card, great for putting on your G-code and things for printing, and it will plug straight into the side of the LCD display, so that's nice. They provided an additional thermistor for the hot end. I guess occasionally these can break, so there's an additional one of those. And then what else was in the bag was a whole bunch of extra shims. The one thing I have noticed right away, this is the cable for the hot end, for the heat bed. So they've actually doubled up the live and negative, the positive and negative cables. So there's 2 reds and 2 blacks. And they've actually crimped them together at the end with a little ferrule. It's not the best ferrule, and there's a few wires that are hanging out, straggling. So what I might do is actually put new ferrules on there before I wire it into the power supply. It's got to go through the MOSFET and then off out to the power supply, but I think I'll put new ferrules on there just to keep it nice and neat. Actually, even the mains cables, they're just bare ends of wire that have been tinned, so I'm going to put ferrules on those as well. I like ferrules because it keeps things very nice and neat and tidy, and if you can have access to them, I would recommend that you do that too. So you can see that with the new crimps on here, it gives a much better finish, and any stray wires are protected behind these extra plastic insulation. You actually get kits of ferrules. These are from RS Components, and my crimping tool is also from RS Components. It's stock number 1221791. These are not cheap, but if you're going to be doing a lot of assembly, it's definitely worthwhile getting one. Gives you a very professional finish, a very reliable finish, and this one crimp tool will do a very large range of different crimps. It automatically adjusts for the sizes. So yes, definitely worth having. If you can't do those ones, at least get the other ones that you can get from a lot of car auto stores where you hand crimp them. This one's a ratcheting one, which gives a consistent pressure, but it would still be better than having just the bare wires shoved in a hole. So following this guide, it's an extra leaflet that came with the kit to do with using the MOSFET driver. This shows you how to wire it up correctly. So I'm going to be following this guide. TEVO have also provided some heavy gauge wire for connecting everything up. So using this and following the guide, I will now hook up the MOSFET. So I've now got the mains side of the power supply wired up in here, nice and neat. It's a high-res picture to show you. The next step is to power up the power supply without having anything else connected, just to make sure we do have 24 volts coming out of it. So to be clear, I am using a grounded IEC cable to connect to the mains. So this should be grounded. Now I'm going to just make sure that the ground connection is connected to the case of the power supply before I hook up the mains. I've set my meter to buzzer mode, and you can see here, not very loud, but it does buzz. So connect to ground, and we do have continuity. It is connected, so, and everything else is plastic, so it's almost double insulated if you like. Well, not quite, but we've got our ground, and let's switch to volts now. 20 volt range, nope, 200 volt range, and we will turn this on. Now I know there's live mains here, I am being very careful. So fan immediately starts up. That's going to be annoying that we've got a permanent fan here. That might be a reason to get in there and quieten things down a little bit. So here's our meter. I don't know if you can see that. So we'll see what volts we've got coming out. So 24.1, that's no load, so that's good enough. We can adjust that later if we need to. So that's just making sure we don't have any bad volts coming out. We don't. And the switch works as well. So that's good. So the next step now then is to start wiring in the extra 24 volt devices. Namely 24 volts into the main module, 24 volts directly into the MOSFET driver. The output's already here, and then there's going to be a short cable from what would have been the heat bed output to this to drive the MOSFET. And that's going to run from this bigger connector on the board here. So let me just get that done and we'll see if this whole thing will power up in a moment. Okay, so now all the wiring is done. We have 24 volts feeding into the MOSFET. The output of the MOSFET is feeding off to the hot end, the heated bed. The output of the original board heated bed feeds into the MOSFET board to heat it. We have USB input. We've got to run that, I guess, out the back. All the cables are connected. We have 24 volts feeding into the main board. The only output that's coming on here right now is the hot end. The second hot end and the part cooling fan are not connected. One, because we don't have a second hot end and we don't have a part cooling fan yet. Something we will be adding. The cables are all cable tied up to make them nice and neat. I will take some pictures to show you a closer view. It's probably not the perfect wiring, but at least it's neat and you can follow things easily. And that's pretty much it. Anyway, so here we've got the main board, the cables going up to the display, the MOSFET wiring, high powered wiring, high gauge cable. We have all of the power supply connections. At this end we have the rear fan permanently connected, so as soon as you turn it on, this fan will start. That would be something that may be worthwhile changing in the future as well. And power supply is screwed in. Mains runs off separate side over the top to the switch and back to the power supply. LCDs connected, buzzers connected. Everything's done, so time to move forward. Okay, so now everything is put together. All the cables are all tidied up reasonably anyway. The TEVO itself is all wired up. If I move the camera, you can see it's all the connector bundle at the back. I don't really like that too much, but they need a bit better security on the back of that box. The box itself is covered up, a little bit noisy with those fans. And here's our display. The next thing to do would be to do a full auto home. I've just finished tramming the bed. So we go prepare, auto home. And there we have it. Now, a couple of things I've noticed. One, if I move the bed in the x-axis, what we'll find is we're going to run out of, right, it's just about to touch the side, and you can see there's probably 2 inches of bed that is not being touched there, which is not good. And on the other end, see, ram against the stops, which tells me that the distance has not been set up. Now we're at almost 0. So we're right on the edge of the bed there, and it's 2 centimeters from the 0. So we can get to that side no problem. The trouble is getting to the other side, so I'd have to figure out losing a bit of bed space there. Let's try the Y. Alright, we've run out of Y movement and we're about 1 inch off the edge of the bed, which is, I guess that's okay. But we can go off the bed this way, so we've got a bit of movement we could do to shift that, I think, because I don't think we're at the end of travel. So if we adjust the 0, it's obviously running on a limit there. And then the final one is the Z-axis. Which is faster. So obviously the limits are not set right because it's not, well, there we go, it's just intermittently, it's not reading this encoder as well as I would like. Set it to 150. That's 200. That's 240. So yeah, we're just touching the belts now on the top at 266. So 260 is the maximum height we have on this. I think the box was telling us that we had something slightly different. Let me just check again, because I think it was, well, more. Yeah, 400 by 250 by 300. So the X is 400, the Y is 250, and the Z is 300. So we're not getting the Z height there because the cable chain is getting in the way. But that's still quite a big build volume. And on the X, let me just go back to the X, it said it was 400. 300. So 378, anything more it's going to hit the extruder motor here is going to hit the edge of the frame. So it's almost, we've lost about 20 centimeters, but that's about what we had down here. So if we can get this extruder probably move forward slightly, would do it, so that it is not hitting the side frame, that would probably fix that problem. Not a big problem, but a problem nevertheless. Anyway, let's do another auto home just to save me having to wind all these back again. And we'll call that complete for, well, sorry, we'll do one more quick test, and that is heating the hot end and heating the bed just to make sure they do heat up. Haven't tested that yet. Now, the one thing that's missing here is a spool holder, of course. That filament goes in the top of that extruder, and there's nothing to mount the filament on. Now it is a big solid base top, so we could mount something up here quite easily. So what are my thoughts so far? I actually quite like it. I think it's simpler than the TEVO X5S to assemble. I think there'll be less problems with having to repeatedly tram the bed, because with the TEVO being the Core XY and the independent motors, the bed does tend to drop a little bit on gravity when the motors are disabled, i.e. when you have the thing powered off. So when you power it up again, you have to try and retram it, at least at the end points, maybe not all 6 points or whatever, but you do have to do the end points just to make sure it hasn't dropped a little bit due to gravity. With this one, of course, because the bed is fixed in a fixed plane, you shouldn't have to do that. And because the X-axis is sharing one motor with a belt between the two sides, then it should never get out of alignment either. So I'm quite happy with that. Now the only thing left is to do a preheat. So we'll just do a prepare preheat PLA, and we'll just say preheat PLA. We'll do the bed as well as the hot end, and we'll see what happens. So we set the hot end to 180 and the bed to 70. Let's see how long this takes to heat up. This is assuming I've wired everything up properly, of course. So the hot end is already up to 100. The heated bed is already up to 30 degrees, which is pretty fast. Just going to move the camera and point it at the screen instead. I think that will be more useful for people. So it looks like we're almost already up to temperature on we're up to temperature on the hot end. Actually, we slightly went over. And we're up to 42 already on the heated bed. But let's give that a few more minutes and see if it actually reaches 70. So that's already up to 50. That's the benefits of having a 24 volt power supply. It's getting quite nice and toasty on that heated bed now. Yep, that's just sailing right by, which is nice. I will go put a little test cube or a Benchy or something on the SD card, and we'll try and print that straight from the thing. I think everything is now set up on here. No smoke coming out of anything. And there we are, up to 70. So I'm going to grab an SD card. I've got to go put Benchy on it, and we'll see if it prints.